Okay, so let's begin our discussion. So I'm sharing my screen. Okay, so as per discussed, we will be discussing these six problems, and I'll be explaining the fourth one and the sixth one. If anyone would like to explain the rest of the problem, you're most welcome to do that. So I think Rihan is supposed to explain Kadane's algorithm, the fifth problem, fifth editorial. So first, I'll go with the explanation of the fourth problem, then he will explain the fifth one. Okay, just a minute. Uh, can anyone just speak? I'm just checking the mic audio. Just confirm. Second, just a second.
Hello.
Yeah, okay, it's audible. It's getting recorded. Thank you. Okay, nice. So the problem over here, the fourth problem is merge two sorted arrays without any extra space. So if we look at the problem, it's like this. We have two arrays, and what we need to do is we need to rearrange the elements, and we don't need to print them. We need to rearrange in such a way that overall they are in a sorted fashion. In the article, it is mentioned that the given solution is of O of m into n, that is n square complexity. But if you look at the question accepts O of n log n complexity. That's why if you try to run this code, which is present in the editorial, it won't get accepted because the complexity accept which is allowed is lesser than what's given in the editorial. So I searched through some comments in this question and I got a pretty nice solution of it. So the idea behind this whole solution is first we observe that this is the sorted order, and in the sorted order we can see that 18 is present over here in this array, 25 is present over this array, 10 is present over here, and 17 is present over here. So basically this is the left array, that is I'll call A, and this is the right array which I'll call B. So from the array A, what we need to do is we need to move 18 and 25 towards the right array, and from the array B we need to move 10 and 17 from the towards the left array. And what we're basically doing is we basically transferring the larger elements towards this array, and we're transferring the smaller elements towards this array. If you can, yeah, yeah, okay. So that's the whole idea about this. Since the elements present in the right array after being sorted are greater than the elements present in the left array, therefore what we need to achieve is separating all the larger elements and getting them transferred to the um, right array, and doing the same for the smaller elements. So how do we achieve that? If we observe, if we can see, suppose if we compare the 15 and 10, so 15 is obviously larger than 10, and as per the intuition we must swap these elements. But if we do so, we won't be achieving the desired result, because as you can see the 10 and 15 stay in the same array. So this method won't work like randomly checking which element is larger. So we need to move strategically. So for doing so, we can do is we can move from the rightmost position in array A and leftmost position in array B. And why we are doing so is because If we move from the rightmost position, what we're doing is we are fetching the greatest element, and over the array B, we are fetching the smallest element, and we are seeing if they can be interchanged or not. And if the element over the array A is larger, then obviously it is supposed to be present over the right array. So just a second, someone join. Okay, sure. Where were we? Yeah. So we are going to use two pointers for 25 and just uh, click on admit so that everyone can join. Okay, I don't have to do it again and again. Anyway, so let's do that. We need two pointers. We have one point over here, one point over here. So if we check 25 is greater than 10, we can replace these, swap these basically. So we have got 10 over here and we have got 25 over here. Then we move the iterator and we got these two numbers, and 18 is obviously larger than 17. Then we're going to swap them. 17 with, over here we've got 18. Then we're gonna move, increment the pointer towards the right side and decrement over here. Then we'll compare, and at this point of time 15 is smaller than 28, hence we're not gonna swap it, and we will stop over here. But at this point what you can see is we have 2, 7, 17, 10. We have 25, 18, 28 and 30. The only thing which is left is to sort these individually and convert them into the desired result. And before sorting, what we achieved is we achieved that all the smaller elements are present over the left array and the right array, and the larger elements are present in the right array. So let's see what's the time complexity of it. So by iterating through the array using the pointer, it takes probably n operations, and over here maybe m operations. And if we sum them, we get O of n operations. Okay, let's make this n little neater. And after this, we need to sort this uh, both of the arrays, which will take n log n time, the fastest sorting algorithm, that is quick sort. Okay, n log n time. And add them, if we add them, then we'll be getting 2 of log n, and finally n log n, sorry, 2 of n log n, because we are sorting two arrays, and the whole complexity would be n log n. That's why this solution is getting accepted. And if we can see over here, okay, let's go to paint again. So if we code this solution out, we have one pointer over here and one pointer over here, and we will begin with this. Suppose this pointer is I, and suppose this pointer is j. Mhm. And in this code, this is the entire code which we are using. Before this, we are just taking input of array 1 and array 2, and then we'll move on to the main logic part. So the whole idea about this is, since this is the pointer, this is the first pointer, that is I, and I have initialized it to m minus 1, because this is the m minus 1 position, and this is the 0th position, this is the 0 position, and this is the n minus 1 position. So for the first pointer, we initialize it to the last element. Then for the next pointer, we initialize it to the first element, that is 0. And now we do the first step, that is moving both of the pointers and over here. And we do the comparison like we did over here. And in the comparison, what we see is if the element in the first array is greater than the element present in the second array, then we swap both of the elements, which basically means we are transferring the larger elements to the right array. And in case we come up to the point where we have 15 and 28, where the first element is not larger than the second element, we simply break, because we by that time we have already made sure that all the small elements are in the first array and the larger elements are in the second array. So that's the whole iterating through both of the arrays. Then all we are left with is sorting in the individual arrays, for which I used sort function. I'm coding in C++, so there's an inbuilt sort function which uses a complexity of n log n. Hence, the entire complexity of this logic is n log n. Now let's test it out. Okay, and yeah, our code is successfully compiled, and let's submit it. Yeah, it's accepted. Just for a reference, I have obtained the solution from somewhere around here. It should be, yeah, this guy. So this guy suggested the whole solution, and the complexity is in login. Okay, so I'm done with this question. I hope it's pretty clear. Anyone has any doubt regarding this question? Okay, so I think it's pretty much clear. So, Rihan, would you like to explain the fifth problem? Yeah, Manjusha, you printed that out. You know the.
Yes, bro. I would like to explain. Uh,
Yeah, yeah. Go
Hello.
on, go on, go on.
Am I audible to everyone?
Yes, you are audible.
Hello.
Yes, you are audible.
Okay. Let me fill the SMS. Okay.
Okay.
Is my screen visible?
Stops.
Hello.
Yeah, your screen is visible. Just a second before we move on. Someone has any
So
doubt?
today I'm.
I'll be clearing that. Then we shall move on. Rahul, the time complexity is O of n plus 2 n log n. Yeah, and if you notice that n log n is greater than n, so that's why the result resultant time complexity would be n log n. Is that clear?
Yeah, thank you, thank you.
Okay, sure.
Yes, yes.
Okay, so carry on with your example explanation.
Uh, yeah. So my screen is visible, right? I have opened the Geeks for Geeks website. So today I'm going to explain the Kadene's algorithm. So the another name for it is largest sum contiguous subarray. So array is basically a data structure where all the memory blocks are attached to each other. Depending upon the size, we can reach the next block. So our main motto is to find the largest sum continuously in a subarray. So subarray is a part of an array. Like it should be continuous. It should not be like first element then the last element of the array. No, it's not going to be like that. It should contain the first element, second element, and third element continuously. So given an array with some values, we are going to find a sub array in which which has the largest sum. So as you can see the below example, like -2, -3, 4, -1, -2, 1, 5, and -3. So we are going to take some parts of the array, like we are going to take -2 and -3, which gives us -5, and we are going to keep on comparing with the sum that we have obtained. So in the example, you can see like that 4 -1 -2 1 5, upon adding you are obtaining 7. So this is the largest sum because upon adding other elements also you are not going to obtain so much of maximum value. So Kadane's algorithm takes a time complexity of O of n, where n refers to the size of the array, and it takes a time complexity of O of 1 because we are going to use the constant space, like the which is the array given itself. So here I am going to use two variables as shown in the here, like max so far and max ending here. So max so far is a variable which keeps the count of global maximum value, and max ending here keeps the value maximum value up till a particular element. So let's take the example, like I am adding -2 and -3, which gives us -5. So -5 is max ending here, that is maximum value till the first index of the array. So like max so max so far gives us the global value like -2, -3, -4, like both the values keep on changing. So as shown here, so the standard that is the non-optimized version of Kadane's algorithm is shown here first. So max so far, max ending here is done. Then we are going to loop through each array element, and we are going to add max ending here, like every element -2 plus -3 we are going to add. If max so far is less than max ending here, we are going to initialize max so far with max ending here, and if max ending here is less than 0, we are going to make it max ending here as 0. So the issue with this algorithm is, what if we have the only the negative elements present in an array, like in here in above example, like 4 is positive, 5 positive, 1 is positive. What if just negative elements are present? Like this algorithm, we are going to get a maximum value of 0, which is not possible. So we have to find an alternate path. So even if we can obtain, like we have to obtain minimum negative sum, which is maximum. So there's an alternate algo suggested here. You can go through this article. Each and every iteration is given, so it might be easy for you guys. So this algorithm, as you can see, this even handles the, what to say, if all the negative numbers are given. So first we have taken two variables. Max so far indicates the sum that we are going to maintain it as a global sum variable, and current max indicates through each iteration what maximum value is coming out. So okay, so max so far is initialized to the first element, and current max is also initialized to first element. So in order to save the time complexity, since we have already stored the first block, we are going to start it from the first block of the second block of the array memory. So like we are going current max, we are going to take maximum of the index value, like -2 and -3 is given, right? So current max is already -2. So here current max is equals to maximum of a of I comma current max plus a of I. So -2 comma -2 plus -3. So -2 comma -5. So which is maximum among -2 and -5 is that the number which has less negative value is maximum. So -2 is maximum. We are going to store it in the current max, and max so far, that is which is going to store our global sum variable, is going to be the maximum value of max here in the first iteration. Max so far was initialized to a of 0. So a of 0 -2 comma current max -2 the current max comes out to be -2. So we are going to keep on iterating through it and keep on solving. We are going to obtain 7 as the largest sum. So another commonly asked question is, which algorithm paradigm or which approach we are going to use here for Kadane's algorithm is, we are using dynamic programming. Dynamic programming, we are going to solve smaller problems at a time and store it in the memory locations. This is dynamic programming. So here we are, every time we are storing it, storing like max so far is storing the global maximum, and current maximum stores when we are adding the values at a particular time in an array to our current our maximum. So this is dynamic programming, storing on the results, solving the smaller problems, and by solving the smaller problems, we are conquering or solving the entire problem. So this is dynamic programming, and we are even storing the results. Any doubts? Hello?
So I'll be presenting the sixth problem, that is the sixth editorial basically. Uh, okay, yeah. So the sixth problem is merge intervals. Okay, is it this one? Yeah, it's this one only. So this problem is very simple, but it can be a little confusing to visualize. So I've drawn certain diagrams to make it simple. Okay, so I'll be going over this. Yes, everything's fine. Just checking the audio. Yeah, everything's fine. Okay, let's begin. So the first thing is, suppose we are given an array. Okay, and what we need to do is we need to, as per the question, what we need to make merge all the overlapping intervals. So if you look at the diagram, and I have taken a random example. So over here, if you can see the common part over here, this is overlapping. We need to merge this, and several other parts such as over here, which is overlapping, and we need to merge it. So since we are given this array, suppose we are given this array, and we visualize it in this format, we can see that there are several overlaps. Now to solve this problem, a very naive approach would be basically looking at the first interval, then starting to compare with the next interval, then the next, then we will compare with the next interval, that is the fifth one, like over here. And of course these will overlap, then after that overlapping these two, then sorry, after merging these two intervals, we'll compare with this one, and because this is out of bounds, then it won't be getting merged. But there's a issue with this problem, is because if we iterate through this array only once, we are leaving out certain intervals because they are not overlapping with our first iteration. So what we can do is we can check for every interval and compare with rest of the interval. And by doing so, what we are doing is we're comparing this interval with this interval with this, and this interval with this. And the comparison is basically checking whether there is an overlap between the two intervals. So for every interval, we are for the first interval, we are comparing with rest of the interval, that is n minus 1. And for the next interval, again we compare with the remaining of the intervals, that is 1, which takes 1 into n minus 1 operations, and so on till the last interval, n minus 1 comparisons. So for every interval, we are having n minus 1 operations, and the total number of operations would be n, and which calculates to n into n minus 1. That is, the complexity turns out to be n square. Hence, this approach is a brute force approach. Now we need to make it a little better. So a thing could be done. Now, why we are comparing again and again? Because we are left leaving out certain intervals. Hence, what we need to do is we need to sort out the intervals with respect to the starting time. Now, since we have sorted them out, just a second. Okay, this makes it a little easier because we don't have to worry about leaving out certain intervals. So if we observe over here, first of all, what we'll do is this is our vector this is our vector, the pink array, and we will push back the first interval which we are currently at, So we'll push in the first interval. Then what we'll do is we'll compare the first interval with the second interval, and we will see whether the interval overlaps. So the 6 is greater than, so yeah, so the end time of the first interval is greater than the start time of the second interval. That means it's overlapping. Okay, so we will merge these two intervals. So let's merge these into intervals, and after merging these two intervals, what we will get is 1 is the starting point and 9 is the ending point. Then what we'll do is we'll update the last inserted element, and we'll keep it into the vector. Now we'll do the same again. We'll compare the end time with the starting time of the next interval. So with that, what we'll be doing is, if it is overlapping, hence we will again merge them. Okay, so the same thing goes for here. Um, then it's a little tedious, but let's do it anyway. Sorry, since this is overlapping and the endpoints are 1 and 9, hence we won't change the vector. Then in the next, when we again compare, then we'll be seeing that this is overlapping, and hence we'll merge them. So the final would be initial time would be 1 and the final time would be 10. Hence we will be removing, and we will update the end time only to 1 comma 10, which will be like somewhat like this. Let's make it a little smaller. Yeah. And finally we see that the remaining interval is not overlapping, and hence we will keep it as it is, and that's why it will be like this. And what the final thing which we need to do is we need to insert the element over here, and that's our final result. So by doing so, we have two operations which we need to focus on while comparison. We come across two cases. The first case is whether it's overlapping. The second case is it's not overlapping. So in the second case, the end time of the current interval is smaller than the start time of the next interval. That's why in that case we simply push this interval. And if it's the first case, if it's overlapping, we check the end we check the end time with the end time of the next interval, and based on that we'll decide that the final endpoint would be which. So if this is the case, then the endpoint will be sorry, it should be over here. Yeah, the endpoint will be over here, and suppose, sorry, my mistake. Yeah, so suppose the endpoint is over here, so that means the endpoint will remain same. So this is the whole logic about it. And since I'm coding in C++, and we need to check the last inserted element in the vector, that's why I'm using back function, which is a inbuilt function. And in this particular example, we are doing the same. We are, first of all, we're pushing the first element, then we are having two conditions. That is the first condition, when the overlapping occurs, we are simply we are we are checking the two conditions, that is if it is this case or this case, and based on that we are merging them. And if it's the second case, that is it's not overlapping, that is over here, this one, we are just simply pushing it using the pushback function. And here I'm using the back function to retrieve the last inserted element. It's a simple code. You can go through the solution as well. It's explained over here. I guess, yeah, it's clear. Okay, so I'm done with this question. It's self-explanatory, so I don't think anyone will have any doubt over here. Any questions regarding this? I guess no. Okay, so the rest of the questions are from the practice section. I heard someone was willing to explain the flipping game. Um, So anyone would like to explain that? Because I haven't prepared the diagrams and all for that, so I'm not able to present that question. Anyone wants to discuss any other thing? Because I'm done with my explanation. You guys are welcome to explain yours. Yeah. Um, okay, so if no one is interested to explain, or no one has any doubt, flipping game, I'm not currently okay explaining that because I haven't drawn the diagram and all. Anyone would like to present that question? Or the Abhishek, I think you were comfortable in explaining the first missing positive number. If you can do that. Uh, to be frank, I'm not familiar with that question, so I'm not going to explain that. I'm still confused with that question. So I was hoping someone else would explain that. Mm, okay, so shall we close the meeting because there's nothing to discuss as of now? Any other doubts apart from that flipping question? And okay, यार पहले तो सर नहीं बोलना यार. ठीक है, चलो ठीक है. Let's close this meeting if there's no one explaining the flipping game. Okay, let's close this meeting. Thank you for joining, everyone, and hope to see you next week as well. So, yeah, sure. Post your explanation to the group. Okay. So, okay. Thank you for joining. Bye bye. Good night, and have a nice day.